Hello, my name is Tamir. I'm an engineer at SDF on the platform team. And together with Hemanth from Goldsky, we'll be doing a talk about how to build your own data indexer on Stellar. So for the purpose of this talk, I want you to imagine that you're an issuer of an asset on Stellar. And there's probably two major feature requirements that you would like for an indexer that you can use to monitor everything that's going on with your asset. So namely, you want to track all movements of your asset. You want to see where the asset is moving, and this could be useful especially for fraud to see like which malicious entities are holding your asset. And then the last thing is you want to be able to track the circulating supply. So you definitely want to make sure that whatever is circulating out there on Stellar is matching your internal systems. And if there's a discrepancy, that's probably going to set off an alert. So these are the two product requirements for our minimal indexer that we're going to build. And before I jump into implementation details, I just want to give some fundamentals about how to ingest data on Stellar. The fundamental building block when it comes to data indexing is ledger metadata. So for every ledger on Stellar, there's some metadata associated with it, and it includes everything that's of interesting to note. And so namely, it includes all the transactions that were included in the ledger, all the ledger entries which were modified, and crucially what we're going to focus on during this talk is the events. Events are emitted during smart contract invocation, or they can be, they're optionally emitted. It's up to the smart contract author to write the code to emit those events. And for our use case of a asset indexer, we're going to look at events that were emitted by the Stellar asset contract. And these events are going to occur whenever a transfer happens, whenever a mint happens. And in a recent feature, which got released in Protocol 23, these events are also going to trigger during the Stellar Classic operations. So when you do a Stellar payment outside of a smart contract, from Protocol 23 onwards, you will get events. Sorry? Oh, okay. Okay. Yeah. So that using the new protocol, you'll be able to monitor events from both Stellar Classic and smart contract side using just the same code instead of having to maintain two different code bases for both parts of Stellar. So before I jump into the implementation details, I just want to mention that I will be covering how to build your own ingestion service from scratch using a collection of open source libraries and services that we call the Stellar Composable Data Platform. And then Hemanth will basically show how you can do the same thing, but without having to run your own service, and it's much more streamlined, and that's using the Goldsky mirror product. So the first feature that I mentioned was tracking movements of your asset. In order to do that, we're going to need to parse ledger metadata, which I covered earlier. We have a service that we've developed at SDF called Goldsky. It'll export every single ledger onto S3 or GCS. Goldsky is actually running Goldsky to export ledgers into a public S3 data lake. We're going to be ingesting from that S3 data lake, and once we have a ledger, we're going to use an open source library called the Token Transfer Processor, which is going to look at all the events in the ledger and return only the ones that actually have asset transfers within them. And this library is pretty much tailor-made for for what we're looking to do in order to monitor all asset movements. So the token transfer processor is going to get all of the relevant events and return them in a protobuf form that's easy to introspect. So here are all the possible token events that we get from the token transfer processor. And all of these fields will map onto columns in our asset movements table. So we want to know when the asset movement occurred in terms of the timestamp, the ledger. We want to know which transaction contained it. And all of those are fields that are going to be part of the payload that's returned by the token transfer processor. And the most important fields are the actual amount that was moved and who sent it and who received it. So getting this data out from the ledger into this table, that's a very simple thanks to the token transfer processor library. The second feature I mentioned was calculating the total circulating supply of the asset. So this can be done incrementally. The total supply always starts out at zero. And then the only way to increase the supply is by minting. And the only way to decrease the total supply is through a burn or a clawback. So here I have an example where we just started our asset. Somebody minted 250,000. And then there was another mint of 500,000. So our total supply is bumped up to 750,000. And then there was a burn, which decreased the total supply back down to 500,000. So the data flow is very similar, except this is going to be computed incrementally as a time series. In order to calculate the total supply right now, we look at what the previous total supply was, and then we get the incoming ledger, and we just sum up all of the mint events, and that's going to increase the supply, and then we subtract all of the burn and clawback events, and that's going to decrease the total supply. So it's basically a loop that just depends on the previous total supply. As an optimization, we can exclude any changes, any data points where nothing happens. So our database can be sparse, and it can only include the total supply data points where stuff actually, there was a net positive or net decrease. No need to store data points where the total supply remains the same. So this was a high-level overview of the implementation. At the end, we'll show links to the code where you can see all the nitty-gritty. But the intention was that with this presentation, you have all the details that you need to understand all the specifics, so it'll make it much easier to digest the code. So now I'll hand it off to Hemanth for his part of the presentation.
Thank you, Tamir. That was awesome. So to summarize what we've heard so far, we'll actually zoom out of just our conversation and into the past three, which have all been about data. We've heard about many different ways to access what is happening on Stellar, whether it's Dune, it's Nansen, it's Missouri. So far, we covered, in this presentation, the open source and incredibly powerful way using the Stellar CDP. And I'm going to round us out with one final approach, which is to use Goldsky. So to recap, we are running a public instance of Goldsky and backfilling data into an open S3 bucket for everyone to access completely for free. You don't need an account, you don't need a key, you don't need to tell us who you are. This is being done in partnership with Amazon as well as with the Stellar Foundation. And this is a public good for the entire ecosystem to use, no strings attached. There is a different path that abstracts all of the complexity away. It abstracts away the need for that backing data store powered by Goldsky. It abstracts away the ingest SDK. It abstracts away any transfer processors on top of that, and just gives you a very simple three-step flow. And that is to use Goldsky Mirror. It's a commercial product that asks you three questions. A, what data do you want? B, how do you want to transform and edit that data and filter it? and C, where do you want that data to go? Of course, S3 is a supported sync, as you would imagine, but you can also write directly to a whole host of other types of databases. You can write to transactional databases like Postgres or MySQL. You can write to analytics databases like ClickHouse. You can write to messaging systems like Kafka or SQS, and even to webhooks for push-based notifications use cases. There's a couple of advantages to doing this. The first and foremost is that data quality is fully managed for you. There are continuous 24/7 background checks running on the underlying data lake powering Mirror, making sure that not a single transaction or ledger sequence is missed. Next up, transformations are incredibly easy and powerful. You use languages you already know, like TypeScript or SQL. If you want to do more complex and advanced things, you can pass in your own external handlers. And you can visually and easily chain these transformations together in a way that reflects your underlying business logic. So you don't need to navigate a complex and lengthy code base to manage your pipelines. And then finally, it's fully managed. From the moment something happens on chain to the moment you see it in your database, the P50 time is under 4 seconds. And one additional layer to that is that it's horizontally scalable. What that means is if you want to backfill the entire history of Stellar from Genesis to right now, you just throw more compute at it. Instead of one pipeline, you scale up to 20, 30, 40, and you can have an entire copy of the chain in your own database in about 2 hours. Let me show you what that actually looks like with a real-time demo where we get an indexer built in about 60 seconds. You go to goldsky.com, sign up, log in, and click the new pipeline button. This asks you those same 3 questions that I mentioned earlier. What data do you want? How do you want to transform it? And where do you want it to go? In this case, I'm of course choosing Stellar. And then I will pull up optionally a transformation block to filter specifically for SourceSwap sync data and pull out the changes in the reserves as specific columns. I didn't even write that. I got ChatGPT to do it. It's really easy and a very vibe codable language to use. And then here I hook it up to a hosted Postgres database. You can bring your own. If you don't have one, we will give you one. I hit the deploy button, and in a couple of seconds, Goldsky connects to the database, checks if the table exists. If it does already, it confirms the schema matches what it expects. If it doesn't, it will go create it. For now, I'm going to switch over to a USDC pipeline that I already had running and switch over to a live database monitor to show you what's happening on the Postgres side. The events are streaming in real time with very little latency in the schema that I defined in my transformation with very little effort. It's worth mentioning that this is completely hands-off. Again, you simply answer 3 questions. What data do you want? How do you want to transform it and filter it? And where do you want it to go? And the Goldsky platform will take care of everything else. So to recap our part of the presentation, there's 2 approaches to working with Stellar data. There's the incredibly flexible and powerful open source approach via the CDP. And if you want everything to be managed for you, you can use Goldsky Mirror. Thank you for the time. Really appreciate it. Here's a, I'll wait for a second. Here's a QR code with the documentation, code sample, socials. Feel free to scan it. It will not steal your Stellar XLM.
Thanks so much. Thanks, Tamir. Thanks, Hemanth. That was awesome.